Hey everybody, Mr. Morrell here, and we're going to be talking about homework assignment 11.1. Let me say welcome to the new trimester. That's pretty exciting. We're going to start talking about some geometry, and that will be so great. I'm excited. So to launch this geometry unit, we're going to begin by talking about area, which is a little bit weird because normally when you've talked about geometry in the past, probably you started with perimeter and then went to area. But believe me, there's a very important reason why we're starting with area. So let's jump right in. For question 1, I'm going to go ahead and explain what I think area is, and then I need you to put that in your own words. So for me, area is a measure of the inside of an object. So you kind of look at the inside of an object and you want to say how much stuff is inside. And I want to talk more about that on question 5. So if you want to wait to answer this in your own words, that's great. But when we talk about question 5, we'll get more in depth. Okay, question 2. What is the formula for the area of a square or rectangle? That is going to be the base times the height. Okay? And then the formula for the area of a triangle is going to be the base times the height. And then some people write this in 2 ways. Some people say divided by 2, but it's really also common to, at the beginning of this, say 1/2 times the base times the height. Any are fine. I usually think of it as being divided by 2, but it's a much more common formula to use 1/2 base times height. So question 4, if you know the area of a square, tell me how you could find the side length of that square. So something we know about squares is that all of the sides are the same. They're the exact same. So let's say for a second that we have a square here, and we know that the area is 9, for example. Well, we kind of want to think backwards. Some number times itself is going to equal 9. So that's kind of what you want to ask yourself. Which number squared would equal 9? Let me kind of write that out. This isn't something you would write. This is something like me trying to teach you stuff. So some number x squared is going to equal 9, and we're trying to figure out how much x is. So my recommendation would be to do something called the square root. That's how we undo a squaring function. You take the square root of both sides. And so that's the answer to question 4. How would you find the length of the side? Well, you would take the square root of the area. Okay, so if you know the area, you take the square root of the area. That will tell you the length of the side. And that only works for squares. Okay, let's do questions 5, 6, and 7. And again, as I'm explaining question 5 especially, I'm trying to explain to you more ways that you could answer question 1. So the way that we measure the area of the square in question 5 is we want to know how many little squares are inside of the big square. So when we have a shape and we're trying to talk about the area, kind of the unit of measure is a square inside, and we want to say how many squares there are. So you can see here, one way we could find the area to number 5 is just to count the squares. We got 1, 2, 3, 4, 5, 6, 7, 8, and so on. And we could find the area by counting how many squares are inside. No problem. But what I think most people would find is that that can be a little obnoxious, and we can use some of our math knowledge from before. If we look at how many squares are along the base, so in this example 4, and if we look at how many squares are along the side, or the height, in this example 4, well, we can multiply those together. You say, hey, we've got 4 squares along the bottom, we've got 4 squares up the side. Multiply those together, and our area is 16. Depending on your teacher and what they want from you, some people or some teachers may say they want you to say, hey, there's 16 units squared. What that means is there are 16 of those perfect little squares inside of the bigger square. Some teachers only, I think nobody would fight you if you wrote units squared. In fact, I'll probably keep writing units squared in this video, but you definitely don't have to for some teachers. I'm going to do it, though, because I think it's a good practice. Okay, question 6. Once again, we can go through and we can count 1, 2, 3, 4, 5, 6, 7, 8, whatever. Or, kind of a faster way to do it is to say, okay, well, I know there are 5 squares along the bottom, and there are 4 squares along the side. So if I take 5 times 4, that would equal 20 units squared. Or some people might say 20 square units. That's like a more natural to say what I just barely wrote. Alright, let's look at this triangle and try to understand why there's 1/2 base times the height. So, if I took the base, which is 4, and the height, which is 6, if I multiply those together, I'm going to end up with 24 little squares. Well, it turns out that what you're counting when you do that is that there are 24 little squares in this big rectangle that I just drew. But something else that we kind of know about triangles is that a triangle, especially this one that I just drew, is exactly half the area of that rectangle. So, again, let me re-emphasize something here. I could go through and start counting squares. 1, 2, 3. But the problem you're going to run into is how much of a square is that? Or how much of a square is that? Or how much of a square is that? Once you start getting into partial squares, it's really tough sometimes to see and to tell how much of a square those broken squares are. So, the way that we do it is we kind of rely on formulas in these cases. We said 4 and 6. So 4 times 6 is 24. That's how many are in this big rectangle. And if I take 24 and divide it by 2, so I'm kind of cutting this rectangle in half, that's going to tell me that the area of this triangle is actually 12 square units. Okay? That means that all in all, if I piece together all of those broken squares and everything to form full squares, I would have exactly 12 square units. Alright, let's come on down to this part here. Okay, so these are getting a little bit tricky. All of a sudden we're taking these easy shapes and we're tilting them. Now, if you already know how to find the length of the base and the length of the height, that is one way that you could find these areas. You could multiply those together. But I'm guessing several of you have forgotten some of your 8th grade math and the way to do that. And I'll teach you how to do that in this unit, but I'm not going to do that in this video. So, let me tell you a couple of different ways that this can be done. Probably in your class you've been talking about a couple different ways. You could take this shape here and break it up into smaller shapes that you do recognize. For example, maybe you would find the area of this little triangle here, and the area of this triangle here, and phone call. Don't worry, it's just a telemarketer. So like you could find these different areas and add them all together, plus this area right here in the middle, and that would totally work. That's called an additive method, where you add all of these little areas to get a big area. Hold on, I'm going to pause while the answering machine answers. Okay, so that's been like a minute. Okay, so that is called the additive method. The way that I want to do this for right now is I'm going to use the subtractive method, but you're welcome to use, like it says here, any method you'd like. So, additive method means, I'm going to use the subtractive method, means I would figure out how many squares are in this big blue square that I just drew. So, looking at it, along the base I've got 1, 2, 3, 4, 5, 6, 7, along that side. And then going up here, 1, 2, 3, 4, 5, 6, oh, okay. So this is a 7 by 7. So in this big blue square that I just drew, there are 49 square units inside. And then what I need to do is I need to start subtracting these little squares here. So the area of, why did I just say squares? The triangles. So Looking at this triangle, it looks like this has a base of 3 and a height of 4. So the area of this one red triangle is going to be 3 times 4 divided by 2, which is 6. So inside of this triangle here is a total of 6 square units. Well, looking at these other triangles, it looks like that has a height of 3 and a width of 4. This has 3 and then 4, 3 and then 4 again. Okay, so it turns out that all of these triangles have an area of 6. So I could take 49 and subtract 6 4 different times, one for each of those triangles. Kind of interesting. So subtracting these 6's, well, that altogether, the area of all of the triangles altogether is 6 times 4, which is 24. So I could do 49 minus 24. And when I do that, my answer is going to be that that's 25 square, or units squared. Okay? And again, there are definitely other ways you could do it. If you use the additive method, that's cool. If you know how to find the length of those sides, that would also work. You could even think back to question 4 and start asking yourself, how long is each one of these sides? Use question 4 that we already talked about to start asking yourself that question, because that's something we're going to be talking about starting tomorrow. Kind of cool. So question 9, you can use any method you like to find the area of that rectangle. Kind of looks to me like maybe that would be easy. Well, I don't know. You could do additive or subtractive method on there. For question 10, let me show you 2 different ways you could do that. One way is you could do the additive method. In other words, you find the area of this triangle here, and you find the area of this triangle here, and add those 2 together. And I would encourage you to do that if that's easier for you. What I'm going to do is I'm going to use the formula we talked about in question 3 and say, hey, I'm going to do 1/2 times the base times the height. So the base here is 6. Now the height means that you make a right angle from the base and go up to the tallest point. So kind of like this. This is how tall the triangle is. And that looks like a height of 6 also. So I could do 1/2 times 6 times 6, or what I'm more accustomed to doing is 6 times 6, and then dividing that by 2. And again, the reason why we divide that by 2 is if you look here, if I did 6 times 6, that would give me the area of this square. But this triangle is filling, oh my gosh, what is happening? The area of the triangle is only half of the area of that square. Anyway, cool. So 6 times 6 is 36. Divide that by 2, and it looks like the area of that triangle is 8 units squared. What? 8. 18. Okay, let's head over to the next page. Okay, why don't I help you with question 12? So this is utilizing question 4 from the front side. In these examples, I'm telling you the area of a given square, and you need to tell me how long the side is. And I'll tell you why this is kind of saying, when necessary, give both an exact length and an estimated length. Let me tell you why. Well, we discussed on the other side that if I knew the area was 20, the way that I would figure out how long a side was is I would take the square root of the area. Oh my gosh. So, the exact value of x is the square root of 20. And the reason why I'm saying that is because, let me pull out my calculator, when I type in square root of 20 in my calculator, I get a crazy decimal. And anytime you round, you're losing the exactness of your answer. So the exact answer is the square root of 20. And then you'll see this little symbol here. This little symbol, it's like a squiggly equal sign. It means about, or approximately. So the square root of 20, which is approximately 4.47. And I'm not going to say units squared, because remember, units squared, this thing here is 20 units squared. So there are 20 little squares inside of this big square. But, or centimeters squared, sorry. If I had a square centimeter like this, 20 of them would fill this box. Now, if I want to know the side length, then that is just a plain old centimeter, because a centimeter is a good way to measure a side. Alright, let's head down here to level 3. So level 3, there's a couple of things. It's going to tell us we have a weirdly shaped pool, and that we need to figure out how much it's going to cost to buy a cover. The cover charges $3 per square foot. And we'll just assume that this grid is in feet. And the vertices of this pool are -1, 3, 3, 2, oh my gosh, 3, -3, -3, -2, and -3, -1. So our crazy looking pool looks like this. So my help for you, or my advice, is you need to figure out the area of this thing. Since you're being great and watching this video, let me recommend the additive model. I think you could try the subtractive model. Maybe, yeah, you might be able to make the subtractive model work. I just think it might be a little bit messier than the additive model. But you do whatever you feel good about. And then don't forget this big hint over here, that each square foot that you buy is going to cost $3. And the big question being asked here is, how much money is this pool cover going to cost you? Okay, this level 4 question is kind of tricky, but like always, I'm going to leave that up to you to apply your understanding about the area of triangles. I've been trying to drop you hints throughout the whole video to help anyone that wants to work on that level 4 question. And yeah, that's all I have to say about that. I appreciate you guys tuning in. Make good choices, and we'll talk to you later. Bye!